The first chapter was permutation and combination. Okay, let's revise some questions from here. Okay, firstly we'll discuss on the basic principle of counting. Basic principle of counting. It is also called as fundamental principle, and in this fundamental principle we will multiply all the possible events or number of events that can be performed to find the total number of the ways of performing an event. Like if an event can be performed in M1 ways, second can be done in M2 ways, third can be done in M4 ways, then total number of the ways will be M1 into M2 into M3 into M4. So in this way we will multiply all the possible number of the ways. Means if a work W1 can be performed in P ways independently, and similarly another work W2 can be performed in Q ways independently, then the whole work can be performed in P into Q ways. If you assume that P into Q, if you assume as M1 and M2, then it will be M1 into M2. So the independent events can be multiplied to find the total number of ways of the whole event. That is the idea for this. Now let's solve some questions. Question number 1 for this basic principle of counting is, if two coins are tossed at a time, how many different outcomes are possible? Okay, look at this question. If two coins are tossed at a time, now how many different outcomes are possible? How many outcomes? If the first coin is tossed, how many different possible outcomes will be here? There will be two, right? In a coin there are two faces, one is called as head and next one is called as tail. So if a coin is tossed, then there are head and tail. If another is tossed, then there are also head and tail. There are also head and tail means, so here there are two possibles in the first event. In the second case there are also two possible events. That means the total number of the outcomes will be how much now?
4.
Yes, total number of outcomes is equal to 4. 2 times 2. 2 times 2 is 4. Now similarly next is, there are 5 questions in an examination. There are 5 questions in an examination. In how many ways a student can set up his answer? Look at this question and try to get the answer. There are 5 questions in an examination paper. There are 5 questions, like question number 1, question number 2, question number 3, question number 5 and question number 4 and question number 5. Now in how many ways a student can set up his answer? Means Setting up means firstly you will do question number 1, secondly 2, third 3, then 4, then 5. This is one setup. Another setup is you may do question number 1, then 2, 3, 5 and 4. This is another setup. Or he may do 1, 2, 4, 3, 5 like this also. So this type of how many setups will be there? In how many ways can he solve the entire question paper? That is the question.
Yeah. Will be uh,
How much it will be?
what's it called? The 5 exclamation mark.
5. Okay, that is called as 5 factorial.
Yeah, factorial. Yeah, it will
Yes,
be
5
five
factor.
factorial. So 5 times
Right.
4 times 3 times 2.
Right. Or you may analyze it like this also. There are 5 spaces to solve that questions because we need to do 5 questions, right?
Yeah.
We need to do 5 questions, so there are 5 spaces. The first space can be filled by 5 different ways. First, second can be filled in 4 different ways. Third space can be filled in 3 different ways. Next can be fourth space can be filled by 2 different ways, and fifth space can be filled in 1 way. Now we need to multiply all these, means 5 times, 4 times, 3 times, 2 times and 1. So here total number of setups equals to 5, 4,
120. Yeah.
3, 2, 1. 5 was a 20, 23 is a 60, 60 times 2 is 120
120.
ways. This is our answer.
Yeah.
Now next next question is by using the digits, by using the digits 1, 2, 3, 4 and 5 once only. Once only means it is the case of non-repetition. You cannot repeat the same digit again and again. Repetition is not allowed, that means. Once only, how many 3-digit number, how many 3-digit numbers are possible? This is the question. Can you find it?
Yeah.
Okay, what will be our answer? I will add next question also.
Yeah.
Among them, how many are even? How many are odd? Or how many are divisible by 2? Okay, there are 5 different digits, 1, 2, 3, 4 and 5. These are the 5 different digits. Now we need to form the 3-digit numbers. The first question is. Second question, among those 3 digits number, how many are even? Now you should know the condition for a number to be even and odd as well. So what is the condition to be a number as an even or an odd? You should know that condition. If you know, then we can identify those numbers easily. And how many are divisible by 2? So at what condition the numbers can be said as divisible by 2? Have you got your answer?
Yeah.
What is your answer?
First one, I got 60.
60.
Yeah.
How did you do that? 5 times 4 times 3. Is that?
Yeah, like 5 factorial over 5 minus 3 factorial.
Yes, that is also fine. You used permutation concept. That's fine. That's correct. And next is how many are even?
Even, I said 24.
Only 4.
No, 24.
24.
Yeah.
How did you do that?
I did like 2 times 4 times 3
Mm-hmm. Why 2 at first?
because there's two choices of even numbers, which is 2 and 4.
Okay, right, right. Then next is odd.
Odd, I did 3 times 4 times 3, which is 36 odd numbers.
Uh. And then how many are divisible by 2?
Divisible by 2, 24.
24, right. Okay, all the even numbers are divisible by 2, right?
Yeah.
Hmm. Okay. If so, then let's move to next. Next type is permutation. Permutation. Okay, so permutation of n items taken r at a time. Permutation of n items taken r at a time is given by, you can either write Pn comma r, or it is simply can be written as npr also. Its formula is n over n minus r factorial, right? N
Yeah.
factorial over n minus r factorial. So this is the total number of the ways. And at what condition the permutation should be applied? Can you identify the question where we should apply permutation and where we should apply a combination? The question will not state whether you should apply permutation or combination. So you need to identify by yourself. So in what condition we need to apply permutation and at what condition we need to apply combination? What are the cases for permutation? So whenever there is arrangement of numbers, whenever there is arrangement of number, whenever there is arrangement of letters, because in all these cases the order is important, order matters. So these are the cases where we apply permutation. Not only this, so whenever there is the case of arrangement in rows, arrangement in rows, similarly circular arrangement, like a round table, arrangement of the people in a round table, such cases, and similarly the arrangement of beads in necklace or flower in garlands, necklace or garlands. In all these cases we apply permutation, because in all these cases the order is important.
Yeah.
Order is important in all these cases, so that is why we apply. Okay, let's do some questions. Like the first question is, it is required, to sit 5 boys and 4 girls in a row, so that the girls occupy the even places. How many such arrangements are possible? How many such arrangements are possible? Will you try it once?
Yeah.
Try to draw a diagram and then solve. It will be easier.
Yeah.
It is required to set 5 boys and 4 girls in a row. Means there are altogether how many spaces? 9? 9
There's
places?
9. Yeah. There's 9.
1, 2, 3, 4, 5, 6, 7, 8, and 9. Now, what is the condition? There is a specific condition given. So that the girls occupy the even places. There is one restriction here.
Yeah.
We cannot place everyone in every places. Means we can just place girls in the even places. Even place means second place, fourth place, sixth place, eighth place. We can place
Yeah.
girls.
Yeah.
Means according to this, we can place G here, and here must be boy, here must be boy, here must be girl, here must be boy, here must be girl, here must be boy, here must be girl, here must be boy. Right?
Yeah.
This is second place. This is
Yeah.
second place. Second place. Second place. Sorry.
Yeah.
Second, fourth, sixth, eighth. Means these all are even places. In
Yeah.
all the even places, goals must be kept. Goals must be placed. Now, how many total places are there for boys?
For boys, it's gonna be 5. 5 places.
5 places, right?
Yeah.
If so, then in how many ways those 5 boys can be arranged in those 5 places?
How many ways? It'll be 5 factorial.
Right, 5 factorial. Similarly, how many
Mm-hmm.
places are there for girls?
4 places.
4 places. Then in how many ways the girls can be arranged there?
4 factorial.
4 factorial. Now, total number of the ways will be how much then?
Total number will be 4 factorial times 5 factorial.
Right, right. That is our answer. So, boys can be arranged in 5 factorial ways, girls in 4 factorial ways. Then total number of ways is equal to 5 factorial times 4 factorial ways. This is our answer. Calculation you can do
Yeah.
by yourself.
Yeah.
Now, second question. Let's do another question. Another question will be, if three boys and three boys and three girls are to be arranged in a row having six seats, how many total arrangements are possible? If boys are restricted to occupy the even numbered seats, how many arrangements can be made? How many arrangements can be made? Okay, let's discuss on this. Three boys and three girls are to be arranged in a row having six seats. Now, how many total arrangements are possible? And next question is, if boys are restricted to occupy the even numbered seats, how many arrangements can be made? So, what do we say for the first question? The first question has asked us to find the total number of the ways to arrange all those people.
There's then 6 people total and 6 seats.
There are six people and six seats.
Yeah,
Then what will be the total number of the ways by which all those six people can be arranged?
6 factorial.
6 factorial, right. There are not any conditions, so we can just use, we can just find the total number of people, that is 3 boys plus 3 girls, which
Yeah.
will be equal to 6. Total number of ways of arrangement will be 6 factorial, obviously. Now the second condition, one restriction is given there. If boys are restricted to occupy the even numbered places, how many such arrangements can be made? So what can you say for this?
There's 6 seats and the boys are even, so it's gonna be 2, 4, 6.
Altogether 6 seats, right? 6 seats. The question has told us to arrange the boys in the even places. Means we have to place in second, fourth, and sixth, right?
Yeah,
Here B, here B, here B.
yeah.
And in the odd places there will be girls. G,
Girls.
G, G. It means boys have their specific places
Mm-hmm.
and girls have their specific places as well,
Yeah.
right?
Uh,
How many specific places for boys?
3,
3. And girls?
3,
If so, then in how many ways these boys can be arranged?
3 factorial,
3 factorial. And girls can be arranged in
3 factorial,
3 factorial again. Total number of the ways will be?
3 factorial times 3 factorial.
Right. So this is our answer. So here we can say, for the first question, we can say total number of ways. Total number of ways equals 6 factorial,
Mm-hmm.
because we need to add all the number of boys and girls. And second is there is restriction, so that is why we do here, as boys can be arranged in 3 factorial ways, girls in 3 factorial as well, and total number of ways is equal to 3 factorial times 3 factorial. This is our final answer.
Yeah.
Okay, now let's discuss another question also. The another question is, in how many ways can 4 Nepalese and 4 Indians be seated in a row so that Nepalese and Indian are alternate in the row. In how many ways can 4 Nepalese and 4 Indians be seated in a row so that Nepalese and Indian are alternate in the row? Okay, get to answer here. How much you will get?
Okay.
In how many ways can the letter of the word Monday be arranged? At first, we have to deal with this.
Mm-hmm.
Then only how many of these arrangements do not begin with M? Do not begin with M. And then how many begin with M and do not end with Y?
Mm.
There are three contexts. The
Yeah.
first one is we need to arrange randomly all these letters. In second case, it should not begin with M. And third case, it should begin with M but do not end with Y. These are the three cases.
Uh,
What do you say for the first?
First, uh, it'll be 6 factorial.
It will be 6 factorial. Okay, that is correct. Number of letters equals to 6. Therefore, total number of arrangements. Total number of arrangements equals 6 factorial. Okay, it is correct. Now, what do you say for the second? How many of these arrangements do not begin with M?
There's gonna be six. M's gonna like be fixed, so then it's gonna be 5. So then it'll be 5 factorial.
The
But
answer will be
then,
5 factorial.
yeah, like the remaining will be 5 letters left.
Okay, so 1, 2, 3, 4, 5, 6. Now, in the second case, the question has asked here that in how many arrangements the that do not begin with M. It's not the case
Mm-hmm.
of begin with M, but do not begin with M. So for this, we need to find the total arrangement that begin with M at first. So if we make this M fixed, then how many are left here? 5.
5.
So the total number of arrangement here in this case is 5 factorially. You are right on this case. But
Yeah, but then like it's gonna be like also 6 factorial, and then like then you minus 6 factorial minus 5 factorial to get the answer.
now you are correct. Yes.
Yeah.
So total number of ways in which do not begin with M will be equal to 6 factorial minus 5 factorial. Now third case. How many begin with M and do not end with Y? How many begin with M? 1, 2,
So
3, 4,
begins
5,
with
6. How many begin with M and
mm-hmm.
how many do not begin with M? For this, we need to find how many begin with M and end with Y also.
Yeah,
Means M is fixed, Y is fixed. How many total number here?
there's five. Wait, four, four.
4 factorial. If
Yeah,
so, then in how many arrangements it will begin with M and do not end with Y then?
begin with M will be five factorial.
Begin with M and do not end with Y. We need these arrangements.
Yeah,
Means what should we do for this? Begin with M is
like
how much? 5, right?
yeah,
5 factorial and end with Y is
four.
4 factorial. So we should subtract this.
Mm-hmm.
Then this opposite will come. If you
Yeah,
subtract from begin with M
mm-hmm.
to end with Y, then it will come begin with M and do not end with Y.
Yeah,
It is the concept of complement.
mm-hmm.
Okay, so such type of questions were discussed earlier also,
Yeah,
and these are very important type of questions also. Okay, so tomorrow also we'll solve some of the questions related to permutation, and
mm-hmm.
then we'll move to combinations.
Yeah.
Okay.
Okay.
Today you you'll practice
Mm-hmm.
this type of questions. You can practice from your textbook also,
Okay.
regarding these topics.
Mm-hmm.
Okay, let's do this was for today. Or do you have any
Okay.
questions on this today's
No
session?
questions.
Okay, if so, then let's end the class for today.
Okay.
Okay, good night and see you tomorrow.
Good night. See you tomorrow.